Model architecture. The MoE Convergence. Mixture of experts has won the open-weight architecture debate. Sebastian Raschke's newly updated LLM architecture gallery makes that verdict visual. Of the 30-plus decoder designs cataloged, spanning GPT-2 through DeepSeek v3.2, QWEN 3.5, and Mistral 4. Nearly every model released in 2026 uses some form of sparse MoE, often hybridized with sliding window attention, multi-latent attention MLA, or state space layers. The gallery is genuinely useful as a reference wall. Each model gets a one-panel architecture figure plus a fact sheet, and the visual progression from GPT-2's dense MHA baseline to today's 128 expert routed monsters tells the story of 5 years of decoder evolution in a single scroll. Mistral's latest entry lands right on the convergence line. Mistral Small 4 is a 119B parameter MoE with 128 experts and 4 active per token, yielding just 6.5B activated parameters. Small enough for a single 4090 plus 128 GB of system RAM, according to enthusiastic local AMA commenters. It supports 256K context, multimodal input, configurable reasoning effort, and native function calling, all under Apache 2.0. Raschke's gallery entry notes the design is essentially a near clone of DeepSeek v3 with larger experts, fewer routed experts, and multimodal support. The DeepSeek playbook is now the industry default template. But knowing that MoE is the right macro architecture does not tell you what happens inside. Drew Smith spent a weekend performing layer surgery on 6 different model architectures: Dense 32B, Hybrid 9B, MoE 30B, Dense 3B, and a cross-model transplant, duplicating transformer layer blocks and benchmarking the results on 15 LeetCode-style problems. The headline finding: a universal danger zone at approximately 5.056% depth that kills every architecture tested. Duplicate those middle layers and reasoning collapses. Delete them and output dies entirely. They are the model's attention routing infrastructure, the wiring between circuits, not a circuit you can copy. The practical results are more nuanced than the headline. On a weak enough model, Hybrid 9B scoring 4/10 baseline, duplicating layers at 7.584% depth yielded a 75% capability improvement. 3 new problems solved, nothing lost. On the MoE 30B, the optimal duplication point shifted earlier to 3.844% depth, because expert routing creates implicit depth through selection. Triple stacking the best block produced garbage. Cross-model layer transplant was a hard no in all 6 variants. Matching tensor dimensions is necessary but not sufficient, since layers develop model-specific internal representations during training. The minimum viable model for any benefit, roughly 3B parameters. Below that, there are not enough functional circuits to have spare reasoning capacity worth duplicating. Meanwhile, NVIDIA's Nematron 3 Super illustrates the political dimension of the MoE convergence. Early users report the model feels overly locked down, refusing even obviously creative or absurd prompts. The community diagnosis is blunt. NVIDIA's primary customer is the enterprise IT department signing off on a $200K hardware deal, not the developer who wants flexibility. One commenter noted the license even revokes usage rights if you attempt to modify the restrictions. The architecture may be converging, but the governance philosophy is diverging hard. Apache 2.0 on one end, procurement-optimized lockdown on the other. Nematron 3 might only become usable when ABLIT, ERATION/D, ERESTRICTION techniques are applied. Agent infrastructure. From Unix Pipes to autonomous companies. A former backend lead at Manus, the agent startup acquired by Meta, has published a detailed post-mortem of a design decision that runs counter to the entire function calling ecosystem. He stopped using structured tool calls entirely and replaced them with a single run command, interface backed by Unix CLI semantics. The argument is that Unix and LLMs independently converged on the same interface model 50 years apart. Everything is a text stream. CLI commands are the densest tool use pattern in LLM training data. Pipes natively support composition, and a chain like catalog.txt, T vertical bar grep erar vertical bar WCL replaces 3 separate function calls with one. The post's real contribution is the 2-layer architecture separating Unix execution semantics from LLM presentation constraints. Layer 1 keeps pipe data raw and lossless. If you truncate cat output before piping to grep, you get incomplete results. Layer 2 handles binary guards, overflow truncation 200 lines, with the full output written to a temp file the agent can grep through. Metadata footers with exit codes and duration, and stare attachment. The production war stories are illuminating. A PNG fed through cat produced 182KB of meaningless tokens that caused 20 iterations of thrashing. Silent stare on a failed pip install produced 10 blind retries across 5 package managers. These are the kinds of failures that typed function schemas are supposed to prevent. But in practice, the Unix approach with proper guardrails produced more reliable agents at Manus scale. The infrastructure layer below the agent interface is getting its own purpose-built tooling. Agentic Hosting is a new open-source PaaS written in Go, designed for bare metal servers where AI agents are the operators. No web dashboard, REST API only. The stack is deliberately opinionated. One build system Unix packs, one router Trafic, one container runtime gvisor for syscall interception, SQLite for state, AES256, GCM for secrets. Multi-tenant isolation, rate limiting, circuit breakers, and idempotency headers are built in. It ships with Claude code skills and /commands so agents can deploy, provision databases, and check status without writing curl. At the far end of the autonomy spectrum sits Paperclip.ing, an open-source platform for running entire autonomous companies staffed by AI agents. It provides org charts, hierarchies, reporting lines, goal decomposition. Every task traces back to the company mission. Per agent monthly budgets with hard limits, ticket-based communication with full tracing, and board-level governance where humans approve hires and strategy. The pitch is that it works with any agent runtime. Claude code sessions, Python scripts, HTTP webhooks, and that the real problem it solves is not making agents smarter, but organizing them into accountable structures. Whether that organizational metaphor actually scales is an open question, but the design addresses a real gap. Most agent frameworks handle execution, but not governance, budgets, or persistent task ownership across reboots. Agentic retrieval and computer use agents. NVIDIA's NeMo Retriever team has published an agentic retrieval pipeline that topped the ViDoRe v3 leaderboard and placed second on the reasoning-intensive Bright benchmark, using the exact same architecture for both, with no dataset-specific tuning. The core insight: dense retrieval based on semantic similarity is not enough for complex document search, which requires reasoning, iterative exploration, and real-world knowledge. The pipeline uses a receipt loop where an LLM agent iteratively searches, evaluates, and refines queries, with reciprocal rank fusion as a safety net when the agent hits step or context limits. An interesting engineering detail: the team initially exposed the retriever to the agent via a Model Context Protocol MCP server, the natural choice, but found that the network round trips, server lifecycle management, and silent misconfiguration risks were too costly for experiment velocity. They replaced it with a thread-safe singleton retriever living in process, achieving the same safe shared access without serialization overhead. The ablation studies are honest about costs: 136 seconds per query, roughly 760K input tokens per query, with Opus 4.5 as the agent. Swapping to open-weight Llama produced a small accuracy drop on ViDoRe, but a wider gap on Brit, confirming that deep reasoning tasks still benefit heavily from frontier models. Holotron 12B from H Company takes a different path: a computer use agent optimized for throughput rather than single query accuracy. Post-trained from NVIDIA's Nemotron Nano 2 VL on proprietary screen understanding and UI navigation data, it leverages the hybrid SSM attention architecture for dramatically lower memory footprint per sequence. On the Web Voyager benchmark at concurrency 100 on a single H100, Holotron 12B achieved 2x the throughput of the previous Holo 28B model 8.9K versus 5.1K tokens/sec, while improving task success from 35.1% to 80.5%. Low-co operator 4B from Locormine targets the other end of the spectrum: a 4B parameter computer use model small enough for edge deployment. MiroFish offers the most ambitious framing in this cluster: a swarm intelligence engine that extracts seed information from real-world data, news, policy drafts, financial signals, constructs a parallel digital world populated by thousands of agents with independent personalities and long-term memory, then lets users inject variables and observe emergent behavior. The demo shows predictions for public opinion events, stock market sentiment, and even the lost ending of Dream of the Red Chamber. The engine is built on CAMELA's OASIS framework and backed by Shanda Group. Whether swarm of agent simulation can produce actionable predictions remains unproven, but the architecture: GraphRag construction, persona generation, dual platform parallel simulation, temporal memory updates, represents a serious attempt at collective agent intelligence beyond simple task delegation. AI-powered development in practice. A developer used Claude Code Opus 4.6, high reasoning, to reverse engineer a 13-year-old Disney Infinity game binary. No symbols, no source code, no existing RE documentation, and crack a character playset restriction that the modding community had failed to solve for over a decade. The restriction was not a single flag. One function, find playset for character, gets called at 13 different points across 6 areas of the C++ code. Claude helped trace the call graph, identify all 13 validation sites, map which code area each belonged to, and determine the exact bytes to patch. The result, 17 binary patches plus 3 modified data files, completed in under 24 hours. The community reaction, 90 plus upvotes, the most well-known modder calling it better than my method, is genuine. Though some experienced reverse engineers note the problem may have been more about nobody with the right skills bothering to spend the time than about technical impossibility. The real takeaway is that AI coding assistants are now useful force multipliers for tedious, high-context tasks like binary analysis, not just greenfield code generation. For those spending serious time with AI coding assistants, a 2000-hour Claude Code practitioner has distilled his workflow into the Whisk framework. Write externalize agent memory via git log and structured plans. Isolate use subagents for research to keep the main context clean. Select layered just-in-time context loading via global rules, on-demand docs, skills, and prime commands, and compress handoff documents, and focused compaction as a last resort. The core thesis, 80% of coding agent failures stem from poor context management, and the new one-M token window does not fix the needle and haystack problem. Distractors from similar code patterns cause confident hallucinations. The most practical insight is using subagents for research in parallel, then loading only the 500 token summary into the main context. A 90.2% token reduction that Anthropic's own research supports. On the tooling side, an open WebY community member built an inline visualizer plugin that replicates Anthropic's new interactive inline visuals for any model. The killer feature is a send-prompt JavaScript bridge that lets elements inside rendered HTML/SVG send messages back to the chat. Click a node in an architecture diagram, and the model explains that component. Tested with Claude Haiku 4.5 and QWEN 3.5. 3.5BA 3B, no external dependencies required. Meanwhile, Agentic QEV 3.8.0 continues the evolution of AI orchestrated quality engineering, now featuring 18 specialized agents built on Lion AGI orchestration with PAC principles. Proactive, autonomous, collaborative, targeted. The framework bridges London School Mockist and Chicago School Classicist TDD approaches, with session-based test management and self-healing test suites. Privacy, billing traps, and developer trust. A new ArcSev paper audits what LLMs actually associate with people's names, and the results should concern anyone who has ever interacted with a chatbot. The researchers introduced LMP2 language model privacy probe, a human-centered audit tool tested across 8 LLMs, including GPT-4o. For well-known individuals, models confidently generate values across multiple personal data categories. For everyday EU residents, GPT-4o generated 11 features with 60% accuracy, including gender, hair color, and languages spoken. The critical finding, 72% of participants wanted control over model-generated associations with their name, raising hard questions about whether data privacy rights under GDPR should extend to inferred associations and LLM weights, not just stored data. The paper bridges the gap between theoretical memorization risks and empirical measurement of what models actually retain about specific individuals. On a more immediately painful note, if you use LangFuse for LLM observability alongside evaluation tools like DeepEval, check your usage dashboard. The LangFuse SDK attaches to the global open telemetry tracer provider and greedily intercepts any span with Gen AI attributes, even from completely unrelated tools running in the same process. Because LangFuse has per-trace pricing, this silently inflates bills with third-party background data. The fix is a should export span filter that locks the span processor to only accept LangFuse SDK calls, which is arguably the default it should have shipped with. This pattern, SDK instrumentation that captures more than disclosed, is becoming a recurring theme as the observability stack for AI applications grows more complex. The Ministry of Testing's latest newsletter highlights a related trust boundary: authentication testing. Viola Lykova argues that teams spend disproportionate effort testing login page UI while neglecting high-impact auth journey tests. The actual security-critical paths like session fixation, token refresh races, and credential stuffing resistance. The Agentic QE angle here is pointed, as AI agents increasingly handle authentication flows. The gap between testing the login form and testing the auth system becomes an exploitable surface. The broader pattern across this cluster is an erosion of developer trust on 3 surfaces simultaneously. Models memorize what they should not. SDKs phone home in ways that generate surprise bills, and auth systems built for human cadence fail under agentic speed. AI adoption and market intelligence. Trump code is exactly what it sounds like. An open-source system that applies brute force computation to find statistically significant patterns between presidential social media posts and stock market movements. Built by a Taiwanese developer based in Japan, it has analyzed 7,400+ Truth Social posts, tested 31.5 million model combinations, and distilled 551 surviving rules that passed train/test validation. yielding a claimed 61.3% hit rate across 566 verified predictions z=sign 5.39. The key discoveries include that pre-market relief posts are the strongest buy signal April 9th, 2025, S&P plus 9.52%, that the naive tariff short trade is 70% wrong, and that Truth Social publishes 6.2 hours before X, creating a trading window. The system runs a daily pipeline with 3 brains: Opus for deep causal analysis, an evolutionary engine that breeds new rules from survivors, and a circuit breaker that pauses when performance degrades. The statistical disclaimers are appropriate. 31.5 million combinations tested means surviving models likely include false positives from data snooping bias. But the architecture is genuinely interesting as an application of evolutionary AI to market signal extraction. New data from Anthropic maps Claude AI usage across 116 countries, indexed to working age population. Israel leads at 4.9x, followed by Singapore 4.19x and the United States 3.69x among countries with 10,000 plus conversations. The pattern favors small, tech-driven economies. Because the index normalizes by workforce size, places like Malta 2.8x and Georgia 2.17x punch above their weight. Brazil ranks high in raw usage but drops to 0.7x adjusted. Within the US, Washington, D.C. leads at 4.00x, unsurprising given the concentration of professionals, while West Virginia trails at 0.25x. The most telling finding may be the usage pattern split. Lower-income countries use Claude primarily for homework help and programming tasks, while wealthier countries show a broader professional mix, a pattern that likely reflects both age demographics and economic access rather than any intrinsic preference.